Hi everyone, this video is about building a fast and reliable computer for office or home usage. This is not a gaming PC, but add another RAM stick and a graphic card, it will become decent enough for gaming too. But again, that is not the focus today. This computer is built strictly for office or home usage. We will start with unboxing the components used in this build. First up is G.Skill Ripjaws 5 8GB DDR4 3200MHz CL16 RAM. You may say why go with this pricey RAM, but the reason is its low latency and high speed. You can look up RAM latency benchmarks on YouTube and you will find that high speed combined with low latency in a RAM reduces CPU utilization. In other words, it will make your CPU perform at its best. G.Skill offers limited lifetime warranty, which means that your RAM is under warranty until this model is still being manufactured by G.Skill. In the package, you will get the RAM itself along with a red G.Skill case badge or sticker you can say. Next is Crucial P3 500GB PCIe Gen 3 NVMe SSD. This is a budget segment SSD. I would like to inform you that this SSD does not have a DRAM cache. It uses QLC flash memory chips and comes with 110TB written endurance rating. This means that you can write 30 GB of data every day for about 10 years without any issues. Now question is, how will this SSD maintain the rated speeds without DRAM cache? Answer is that it will utilize the computer's RAM as HMB or host memory buffer, and this is also the reason that why this SSD is cheap. No need to worry about enabling HMB because Windows 10 and 11 supports it natively. But if you are a power user or a gamer, you may want to go for some other SSD which has a DRAM cache like Samsung 980, but that will increase your cost. Also, if you want higher endurance SSD with no DRAM cache, then you can go for TLC flash memory SSDs like Western Digital SN570. But again, be prepared to pay more. This SSD comes with a 5-year of limited warranty. In the box you get the SSD itself, user manual and a tiny screw to install it. In this video however, we will use the one that comes with the motherboard. Next is our 12th gen Intel Core i3-12100 CPU. It has 4 cores and 8 threads. You can also call it a hyper-threaded quad-core CPU. A 12th gen i3 is overkill for the office or home usage, but it was chosen for this build so that even after 5 years this PC remains relevant. By the term relevant, I mean that this CPU remains in line with the hardware requirements of any software or operating system that comes in next 5 years. At the time of assembling this PC, Intel didn't launch any 13th gen i3. We could have gone with that if that was available, but anyway, back to this processor. Another cool thing about it is that it is compatible with both DDR4 as well as DDR5 memory, which means that you don't need to buy expensive motherboards that use DDR5 memory as of right now. In the box you get the CPU with stock cooler. Stock cooler is Laminar R1 and it comes with the pre-applied thermal paste. This stock cooler also, you can notice that apart from the aluminum fins, this cooler happens to have a copper base plate as well, which is good. There's also a user manual that has the case badge or sticker on its first page. Next up is the motherboard. This here is Asus Prime H610M-E D4 Micro ATX LG1700 socket motherboard. This motherboard supports dual channel DDR4 RAM. It will support 12th gen Intel CPUs out of the box, but if you plan to install a 13th gen Intel CPU on it, you will have to update the BIOS first. BIOS can be upgraded very easily with the Asus Easy Flash utility in the BIOS. Also note that this is a Intel chipset motherboard, which means that you should check for Intel Management Engine firmware update as well. This will have to be done from Windows after installing Intel Management Engine interface drivers. Some nice to have features on this motherboard is that it supports 2 M.2 NVMe SSD slots. The top one is directly connected with the CPU PCI Express lanes, but the bottom one is connected with CPU through the chipset. Also, in terms of CPU power, this motherboard will require a 8-pin power connector, so make sure that your power supply has that. That will make sure that your CPU has all the power it needs and doesn't choke on it. In the box you get the motherboard itself, two SATA cables, a right angle one and a simple flat one. An IO plate for the case. A pair of screw and standoffs for installing the SSD. You also get a user manual and a driver CD with it, but do not use the driver CD. Always download and install latest drivers from manufacturer's website. Next up we have the heart of a computer, because this provides clean power to all the components. This here is a Deepcool PM650D 650 watts 80 plus gold rated power supply. You may be wondering why a cheap SSD was chosen previously and now in the power supply you necessarily went for 650 watts and that too 80 plus gold rated. That's expensive, yeah. Reason is obvious, and also because of my personal experience. I have seen motherboard and computer components dying prematurely, all because of cheap power supplies. A good power supply is very crucial in a build. Do not let anyone else influence your mind saying otherwise. This is the cheapest 80 plus gold rated power supply that I could find. 80 plus means that a PSU is delivering 80% of the input power and the rest at 20% is lost as heat. Less heat means more life of your components. Gold rating here means that the PSU is 87% efficient on 20% load, 90% efficient on 50% load, and 87% efficient under 100% load. This particular model of Deepcool power supply is manufactured by CWT or Channelwell Technology. Now in the box you get the power supply itself, a user manual, 4 screws, and a UK standard power cord, not Indian. It's not that. Now with this power supply you get following connectors: one 20 plus 4 pin ATX power connector, one 4 plus 4 pin CPU EPS power, two 6 plus 2 pin PCI Express power connectors for your graphic cards, in total 6 SATA power connectors for your SSDs or hard drives, and 3 Molex power connectors. Here I will briefly show you components again, but in a close-up. Now let's start building. First we install the CPU. Slide the retention arm and open the CPU socket. Align the small triangle on the CPU with the triangle on the socket, then gently place the CPU in the socket. Be very careful while doing that. If you drop the CPU in the socket and any of the pin gets damaged, that won't be covered by warranty at all, and you will have a hard time fixing that yourself or getting it fixed by someone else. For this particular motherboard, you will have to remove the plastic socket cover manually, but do not throw that away because you will need it in case you send your motherboard to the service center. Also, you do not need to rely on the triangles as well for alignment because there are 4 notches on the socket as well as on the CPU substrate, and you will not be able to install the CPU incorrectly at all. After removing the socket cover, turn back the socket flap, and as you put down the retention arm, try to keep the flap upwards. That will ensure even pressure on the CPU to some extent. The alignment triangle is also engraved in the socket flap, so no need to depend on the plastic socket cover for reference. Next we install the NVMe SSD. We will install it in the top slot because top slot is directly connected with CPU PCI Express lanes and will give you the maximum performance. Insert the SSD in the slot as shown and find the standoff position suitable for installing the particular SSD you are working with. After finding the standoff position, install the standoff and use a plier to tighten it down. Then insert back the SSD in the slot and screw it down tightly again. Next we install the CPU stock cooler. I absolutely hate Intel stock coolers because of the push pin mechanism. It is cumbersome to install for newbies and even for the experienced folks. First make sure that the tabs are pulled all the way back and then gently place the cooler pins in the motherboard holes. Turn the tabs anti-clockwise to the max, but do not push them yet. They still need to be all the way back. Next, use your thumbs and some decent amount of force to push the 2 diagonally opposite tabs, and while doing that, turn the tabs clockwise. Repeat the process for remaining 2 tabs. In this video, you can see that the middle pin didn't come in level with the lock studs, and for a proper installation, these pins should be at level to or above the lock studs. I have fixed the issue off camera, but the final result is here for you to see. This is how it is supposed to look in the end. Now, find the CPU fan header on the motherboard and plug the 4-pin fan connector in that. Be careful, it is supposed to be inserted in one way only. Do not force the connector in a motherboard header or else you might damage it. Next we install the RAM. In older motherboards we used to get 2 locking tabs, but nowadays we only get 1. So push the locking tab back as I did and then gently slide the RAM in the slot. Make sure you match the notch in RAM stick with the notch on the slot. Finally, push the RAM down with your thumb so that it is in the place, and the locking tab will turn to the lock position on its own. And that's it. Now we'll post this computer and do some initial configuration. Post means power on self-test. Plug in the power supply. Don't forget to turn its switch to on position. Find the 4+4 pin CPU EPS power connector and insert it into the motherboard. Next, find the 20+4 pin ATX power supply connector and also insert it into the motherboard as shown. Ensure that the connectors are all the way in and the locking clips are engaged. And finally, insert cables for monitor, keyboard and mouse. Short the power button pins to turn the computer on as shown and let it do its post dance. After 2 or 3 self-power cycles, the PC turns on and this message is shown. We open the BIOS and very first thing we test is memory profile. Now our memory is running at 2133 MHz and we know that it is rated at 3200 MHz, so that's the first thing we need to configure. So under the XMP drop-down menu, we select Enabled and then save and exit the BIOS. In the next boot, we enter the BIOS again and you can now see that the RAM is running at its rated speeds. Now I will show you some other useful settings in the BIOS. Switch to advanced mode and under the AI tweaker tab, you can double check that the RAM is running at the rated speeds and latency, that is 3100 MHz, CL16, 18, 18, 38. Now, next move to the advanced tab and find the TPM device selection in PCHFW configuration. Set it to enable firmware TPM to enable TPM 2.0 and set it to discrete if you wish to disable it. After that, we have resize bar support which you should enable in PCI subsystem settings. This is for your CPU to access discrete GPU's buffer and offer a better performance. This is not applicable in this build right now because we are not using a discrete GPU, but this is something you should know. Next interesting feature of this motherboard is QLED core in onboard devices configurations, which will use power LED to indicate components checked during the post boot up. Please read the user manual for more information on that, but it is a really nice option to have in my opinion. Next, under the monitor tab, you will find all the temperature sensor data, voltage monitor, fan speed control and tuning. Next, under the boot tab, you will enable secure boot by selecting OS type to Windows UEFI mode. You don't need to modify the secure boot mode, leave it as is. Lastly, the tool tab. Here you will find the ASUS Easy Flash utility for upgrading the BIOS. Simply download the BIOS file from ASUS website, copy it in your pen drive, insert that pen drive in this computer, enter the BIOS, launch this utility to start the process. Another thing here is the ASUS Armoury Crate installation, which I changed to disabled. It is just a horrible piece of software. You should avoid it unless you are trying to control the RGB lights. That's all, save and exit, you're done. I was not able to benchmark this computer because it was to be handed over immediately. Don't forget to check the description for more information on the parts that I used in this build. Now you can enjoy the glam footage. In the next video, I'll show you how to create and install a custom Windows 11 ISO. Subscribe to my channel so that you don't miss that video. You're gonna love it. Oh, and I forgot to mention the case that we are using here. So it's a pretty cheap micro ATX motherboard supporting case from Zebronics. Its name is Zebronics Magnet ZEB-194B. Despite being a cheap case, I was impressed by the quality of cables of the front panel connectors. And yeah, that's it. Oh, and do not throw away the cable ties. Use them to do cable management. That's all for this video. Hit the like button if you liked it, dislike it if you disliked it. Feel free to drop a comment below. Let me know what more would you like for me to cover. Consider subscribing so you don't miss my future videos. Meanwhile, check out my previous uploads. Thank you for watching. Bye bye.